Okay, so we have this motorcycle or bicycle, and we're saying that it's going a certain velocity, and then when it hits the hill, it's going a different velocity, and the entire time is 230 seconds. So what we're gonna have to do is we need to look at the vectors of the velocity, and we're going to have to subtract the vectors. So you can see the way that I drew it. I'm saying that it's a 17-degree incline. The component of the velocity final in the x and y direction can be found from cosine of the angle times the velocity. So we have in the x direction 18.36. Now this is the x and y components. This is not, one is the initial and one's the final. This is both just the final. So then if you think about the initial velocity, so anyway, that's what we got. You can tell there is more in the y direction. I mean, more in the x direction still, of course. And so look at the initial velocity. We know that there's no y direction of the initial velocity. It's flat. The x direction is just simply what it is said to be. So, let me think here. So now we can just subtract. Oh yeah. We just subtracted the each components. So that's the x from one's the final, one's the initial, and then we did again for the y part of the components of the final and the initial. So then we need to find the velocity, the magnitude of the velocity. Do that with a Pythagorean theorem, as you can see, and that comes to the change in the magnitude. The magnitude of the velocity, change in velocity. Yeah. Which is 3.55 meters per second. Because we have meters per second squared, but we want to think in as simple as possible. And okay, to let's see. Oh, I'm sorry. Okay, so we did ignore the 17 degrees incline because we're saying a similar example I looked at did not include the angle. So we can say that we want to find the angle. No. That's not right. We need to find the angle in the change in velocity. In other words, the vector. We want to know what is this angle. So we did that. We needed to do tangent of what we found. We get 1.29, comes up with 52.3 angle. So the direction in the change in velocity is 52.3 above the negative x-axis. What does that mean? That means that it's actually a very steep hill. And the magnitude of the average acceleration can just be found from what we got for velocity over the change in time, which is 230 seconds. And that's what we get.